Hello, Namaskar, good evening. On 28 February 1928, Sir C.V. Raman discovered the Raman effect, which confirms the particle nature of light, because of which he was awarded the Nobel Prize in Physics in 1930. To commemorate this, we celebrate National Science Day in India on 28th of February. On this occasion of Science Day, we have arranged a special event for you. Today, we will be visiting the Jyotirvidya Parisanstha's Astronomical Observatory, also known as KJO, Kesriwada Jyotirvidya Observatory, because it is established in Kesriwada in Narayanpet, Pune. There we will understand why an amateur astronomer's observatory is important, what was the vision behind creating it, how it operates, and how it is helping professional astronomers. With the sun going down, without any further ado, let's head on.
Hello, sir.
Hello,
How are you?
I'm fine.
So, where are we today?
Yeah, we are at our observatory. This is uh, astronomical observatory, and this is made for amateur astronomers.
Okay, what is the name of this observatory?
This is we call it KJO, and that is the Kesriwada Jyotirvidya Observatory. This is of JVP, that is Jyotirvidya Parisanstha, which is the oldest amateur astronomers association of India. It is formed in 1944, 80 years back.
Wow.
Association was formed there. This dome is that way new, and this is the Tirunja Parisanstha is the oldest amateurs astronomers association of India. Just like I told you, and we do some amateur astronomy here. This basically what happens is most of the people don't want to go into details. They just want to fun of the sky and everything. So the amateur activity is there. And amateurs are very important as far as observations are concerned. Because professional astronomers neither have a time nor the unlimited access to telescope. And we have, so we can do observations a lot because we are in a group. And sometimes what happens if we observe any transient, you can say, something happening in the sky, then it is the only observation at that moment from that particular site or
Location.
and that makes it extremely valuable. So astronomers generally go for, or rather amateur astronomers generally go for variable star observations or the occultations or something like that. And for variable star observations, we build this telescope, this dome. The dome is necessary because as a telescope is inside, you will see now, and it has a it may have a stray light which disturbs the images because we need raw images. We don't want to go for any noise in that. So by the wind, telescope may shiver, by the lights, by the sky glow, we may have some problems. So we constructed this dome, and this is a steerable dome, of course. This is semi-automatic, you can say, and the telescope is fully automatic. This is a 12-inch reflector with a focal length of 1200 and it has a mount which is a observatory grade mount of the sky watcher, and we go for this tripod and everything with that. We have connected one CCD camera for imaging, and that camera is SV7, which is which can be cooled up to minus 20 degrees centigrade. This minus 20 degrees or something like that is essential to reduce the thermal noise of the camera. So now let's go inside and see where our telescope. See how the telescope looks. Now, as this is a automatic, we can operate it from anywhere. So I'm just there are the lights inside.
Wow, the light is on now.
Yeah.
And you operated it with your mobile phone.
The smart switch,
Mhm.
and we also operate our laptop, rather desktop from the remote areas where there is the internet available.
And
So
who
this is
built
the
this
telescope.
built this observatory? Who helped build this observatory?
Actually, this observatory is built by, in my workshop. I have my fabrication workshop in Pune, and I was interested in astronomy and variable stars. So Jyotirvidya Prasad helped a lot, and we go for this observatory. There are this. I can tell you how this observatory is. This is a square observatory at the bottom, and a steerable dome is on the top. It has a slide. The shutter opens horizontally.
Yeah, that is the slit,
Yeah,
right?
that is the shutter, and this is a telescope. This is actually made with MS tubes, that is the pipes, because to make it lightweight.
Mhm.
Then there are some insulation inside, which you can see over here. This is the
Okay.
insulation material that
Why is
insulates.
insulation important?
That insulates the temperature, because outside there is a MS sheet which gets heated terribly in the because of the sunlight. So to avoid the heat coming inside, this insulation works very beautifully.
But
Yes.
why is that a problem in astronomy?
That is not the problem of astronomy. That is the problem of the telescope. If we have a very high temperature in the dome, then our cameras may get spoiled. There are 3, 4 cameras over here which are looking after this all these things. So first one camera is this black one camera. This is the main camera. That is the CCD, which I told, which is the SB67 that can be pulled. Right now we are done it for -7 degrees. Then the red you can see from the camera which is attached to the viewfinder, that is ZWO planetary camera, which acts as a viewfinder. That feed comes to screen with that. Then this is the total mount. So the telescope is 1200 mm focal length. Then what is this? Is a mount, which is a heavy mount, heavy duty mount, and it is upgraded so that our horizon goes up. So as the horizon goes up, we get a from the bottom, we get very less what you can see for turbulence and everything which is on the horizon.
Okay.
So it is lifted up.
So technically, this telescope is very well working if it is placed on the floor. But to avoid the turbulence, we have created a pedestal here, tripod pedestal, and we have put this
Yeah.
telescope
Now,
over it.
what I'm going to do is to open the slit.
All right.
This is while observing. There's one slit, so there is some code is there. Here there is a Raspberry Pi which connects everything. This dome can be connected by auto or manual, and the slit can be done manually or automatic. So this is the algorithm.
This is
I'll
such a
just run
beautiful.
this.
This is such a beautiful setup of very simple electronics and how we can actually do some good astronomy within the city.
You couldn't see the password over here.
Which software
Right
do
for
you
that.
use? Which software do you use?
This is Python.
Okay.
This is Python. We can operate this using browser. So connecting to browser right now.
So we are connecting from Python to the Windows
To the Raspberry Pi.
to the Raspberry Pi.
Yeah. So it is environmental variable 192.168.0.105, and this is the development server is starting. So Webpack is completed. So I'll switch over myself to Microsoft Edge. So you will get this slider and dome. So now we can open our.
Can I have a closer look of that slider and dome? Okay. So is this something that we have set up, or this is something which?
This is completely done by us, by
Okay.
JVP members most of the time. All things here are done by the JVP members. I myself designed all these things. There are 3 motors over here. They rotate in clockwise or anti-clockwise direction. Then there are 4 motors for the slits to open and close. Well, you can just release these buttons over here.
Okay.
And while opening, let's open the thing.
Yes. Yes, please.
Okay, it started opening.
Wow, a perfect center split that we see. A window opening for the telescope.
No, it's right at a daytime, so we'll not shoot any image, but I can show you what we can see from this. Okay,
Sure.
so there are more two cameras are there. So one is at the top of the
The telescope?
OT.
OT.
So I'll take this.
Sir, when you say OT, exactly which part of the telescope are you
The
referring
main telescope, the optical tube.
to? Okay.
This is the optical tube, and now you can see from here that the slit is open. We can see it again by closing and opening. So let's close it out. So get inside part. It takes they are slow as to avoid any.
So why are these cameras important and mounted on
Yes,
the OT?
because when we are doing it from remote places, then we should know what is going on over here. So this gives you full picture of the telescope and slit.
Okay.
Okay. So
Why did you decided to make this observatory a remote?
there are
operable?
two things. JVP is actually very old astronomical association, and many of our members are outside India. So it may happen that when we are at night sky, they will be at there will be daylight over there. So from there they can observe the light. We don't have to spend our night over here sitting there.
We are following the sun model here.
Yeah.
Okay.
So this is one camera which gives you all the things, and there is a second camera which gives you. This is the slit.
Wow.
Let's open the slit. So
That's a
both camera, this slit starts
close
opening.
view of the slit. Is this the ZWO
No, this is not
mentioned
the
that you okay?
This is the another camera which is at the center of the optical tube. So here you can see clearly what is going on. There are clouds, fantastic. So the observations may be delayed today. And from here you can again see this slit has been opened.
Where is this camera placed? Could you please show us?
So one is there.
Okay.
And one is at the center of the telescope, which is called a secondary. The telescope is a reflective telescope. It is a Newtonian telescope. There is one mirror which is convex, and there is a secondary mirror which is flat. The secondary mirror obstructs some part of this mirror. So on the front of that secondary mirror, we attach the camera.
Okay.
So there is no conflict between this camera and the field of view.
So using the blind spot for the advantage.
Okay.
Okay.
So now we'll go somewhere in the east side. So if I pressed east, this new system will start rotating. It is very slow to go. So this is the first thing. I started. With the low move from north to east.
Yeah, we do see it.
Position in the north position.
Is there a specific reason to make the rotation this slow? We could have made it fast, right?
So what happens is actually telescope moves from east to west in the night maximum by say 100 degrees. So it is over 180 degrees over there, but we have to go for the 30 degrees below horizon. We couldn't get the things. 30 degrees below horizon we couldn't. So 60 degrees gone, and so it is almost 120 or 100 degrees sky we can see. It takes around 10 hours to cover these things.
Wow.
So as the Earth rotates,
yes,
in 360 degrees in 24 hours, in 12 hours, it will from 180 to 180. It is less than that. So it is approximately 10 hours we can get for our observation at night.
Okay.
So we don't want any fast thing.
Hmm.
As the telescope moves, this slit should move. So it is very slow. So after say if you are getting a exposure of say 60 degrees, 60 minutes, then after around 15 exposures, you have to move the telescope slit slightly,
Okay.
so that the telescope will see always at the center.
So we do not miss our object.
So we will not miss our object.
Okay.
So what I told you is because of it is semi-automatic. The only part in this that we have to move this slit manually with the button, of course, to follow the telescope or follow the sky.
Okay.
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 So coming again to west side, so we come to our original position, and
So when we click once on that west or east button, what is the degree that this dome is rotating?
around 10 degrees.
Okay.
So it is coming again at the same position, which is the parking position, which is the north position.
Okay.
So there are two things. If you see these motors are on the top of this stationary structure.
Right.
So the problem was that if we have the electrical connections of that motor from the ground, then that creates a problem.
Okay.
So because when the dome upper part of the dome moves, then wires will also move.
Right.
And so there were two alternatives. One alternative, we can use the brush system, which is generally used in the motors.
Mm-hmm.
But for the brush, it was slightly difficult because of the total area one, and we couldn't insulate it properly. Then it may give some electrical shocks or something like that.
Okay.
So we decided one thing, that there will be a one connection over here, which I will show you over here. This is the connection. This is the when this part come to be here, then only
Right.
it will be connected.
Okay.
When it will be connected, the slit opens.
Okay.
When it is not connected, the slit will not open.
Okay. So first we have to open the slit, and after that only we can
first
move
we
the
have to
dome.
match this, then only slit can be opened.
Yeah, I was talking from the parking position of the telescope.
Yeah, parking position, check it whether it is connected. If yes, then open the slit, you will get opening.
So else it won't
And
work.
now if I want to close this will not close right now because it is not connected.
That's
so
right.
we have to come over there
Okay.
and check the things.
What is this section known as, or what is this design known as?
No, there is no such design name as such. This is a stereodome. This is a common actually design. Many of the professional astronomers have this type of design.
Okay.
Even this is on the friction type design. There are three wheels over here. On the motor, you can see here is a motor, there is a gearbox, and there is a wheel.
Right.
And dome is placed on that.
Yeah, this is the wheel we see inside.
Dome is placed on that.
Okay.
And as the wheels moves synchronously, the dome moves. So this is used even in Mount Palomar 200-inch telescope.
Okay.
So when you go this 5 or 6 degrees, you have to shut down the power of the
other motors.
So it moves slightly ahead.
Okay.
Because of the inertia. Because of the inertia. So now we are going to dome for the west, so that will be get connected. Okay. Now I can close the system.
Okay.
Otherwise I couldn't.
So this is to avoid the jumbling of the wires, right?
Yeah. Yeah.
Okay.
And very low maintenance.
Awesome.
Because the brush gets disturbed because of the rotations and everything, they have to replace. This system is called circuit breaker.
Okay.
It breaks the circuit. Actually, we are using in the opposite way. It is actually used for break the circuit.
Break the
And
circuit
we are using it for joining
to
the
create the circuit. That's amazing.
just Indian
The Jugaad system,
Jugaad
of
system.
course. That's how we work.
So you can say there are four what to say cameras which operates all these things that can be used from the mobile. That also I can show you. Right now we are using remote PC, which is a paid software, and that is okay one. There is no issue in that. So this is a remote PC. I am connecting to that, and from mobile this is KJO new PC, which I am connecting.
It's remote PC. Okay.
It's remote PC. So it establishing the connection with my mobile is establishing connection.
This enables us to do it remotely.
Yeah, we can do it remotely. We will do this again also. So this is what you are seeing right now.
Yeah, we do see the same thing on
Same
the
bulb
screen.
screen. So if required, I can open the slit once again from here. The slit is open from the mobile. Anywhere in the world I can operate this.
That's amazing. So, was it always an idea to make this observatory remote, or
Yeah.
is
The first idea was to make an observatory. There was we made a first observatory before this, which is a circular dome. And the walls are also circular.
okay?
And we just do observe from that dome for 4 to 5 years that whether we are getting good results or not.
Okay.
While investing more and more, let's check for one thing. So we done this type of dome, which is a 10 feet diameter, that is 3 meter diameter from inside, and the walls were circular. So we don't have this corner space in that, and that functions fantastically because the steroid was gone. We knew the noise was reduced and everything was there because it was in a slit. So that was fantastic. Before that, we were using our telescope just outside here.
That must have been a problem.
Yeah, and that was giving terrible problem because of the shivering of telescope.
That's right.
Then because of the wind and everything, then all light is coming over here.
Right.
Now to reduce the light pollution, we have done one thing. In this camera, there is a filter wheel. This filter wheel is, I close it so you will get contrast. This filter wheel allows only few wavelengths to the camera.
Okay.
So we are operating in P filter. Then as you know, there is a electromagnetic spectrum which ranges from red to P.
Right.
And we are using some specific point of that, which is the 490
angstrom, nanometers.
Not angstrom. And because of that, the red light in this area or street lights couldn't pass through the pass band.
Okay.
They are filtered.
Okay.
So what pollution will be there in that small thing? Only we receive that.
Okay.
So that gives us
images.
Read of other
okay.
light sources.
By default, it cancels out.
That cancels. That doesn't reach to sensor. The only allowed thing that is called as pass band. This is the V pass band.
Okay.
And this pass band gives a very narrow pass band, and all the other things are filtered. It's like the red and copper.
Oh wow!
So it only generally they are called as they filters the light. They don't filter the light. They pass some light. And others are filtered. So it's a pass band.
Right.
So this camera is a wonderful camera for that. And as the filter means, we can go for different frequencies that we can do for the V, as I told. Then we can go for red. Then we can go for green. So if a star is red, then if you use the blue for filter, then you won't get a star in the future because red is blocked.
Okay.
So when you are coming to the red, observed in the red, you will get the maximum intensity
Okay.
because only that is
Only
allowed.
red is allowed.
Only that is allowed. So you won't get a blue in that.
So we will get a black image. We won't basically get an image.
Get image.
Okay.
That is the thing. So if you some stars are like sun. They are yellow stars.
Right.
They contains all the things.
Okay.
So if you get it red, you will get a red sun. You some part of that because in the red infrared actually near infrared, and some is blue. So because there is everything going on, and the sun's color is yellow.
Yes.
So we'll get all these colors through the sun. But for stars, if they are newly born, then they are blue. They are when the stars are coming to the death, they are generally red. Sometimes there are so many things why star gets dead. But sometimes many a times it becomes a red giant and it becomes a red. So from that we can go for what type of star it is.
Okay.
Another thing or other very important thing when we draw some colors on our paper, what we generally denote is red, denote red as a hot, very hot.
Right.
And blue or green is a
Cool colors.
cooler colors.
Yeah.
In nature, it is opposite as far as stars is concerned.
Oh, is it?
Yeah. This blue star is the hottest star.
Okay.
And red star is the coolest one.
Oh, okay.
So for observing all these things, we should know the colors, and generally they are given by professional astronomers. We don't have to work on that. What we do here, we image the things.
Okay.
And there are variables which are generally known or not known. We are doing on both basis. And
so when we say we are imaging the things, is it something that is those data are already present out there in the internet, or they are something new?
You can say past data. Present data you are taking.
Okay.
So if that data is correct or not, we have to judge.
Oh, okay.
So they are called transients because let us say we are observing some eclipsing binary. So this binary is what is the two stars, but they cannot be separated or resolved from big telescopes also.
Okay.
They are so near.
Okay.
They are moving so fast like this. And as they are stars, they are big and they are revolving each other. So by centrifugal force, they have the period is very less sometimes. And there are many things happen. Like if the two stars are like this and there is no connection between them, only the gravitational pull or they move on the common center of gravity. So as you couldn't resolve, what you get is the two stars like this, then you get the maximum energy, maximum photon to a center, then minimum center, again maximum, again minimum. Okay, so you'll get a good graph like this. So we're going to is straight up, then straight down, then horizontal, straight down. These are called alveol type variables.
Okay.
When these two stars are connected each other, there is a mass transfer. Then there is something issue. Of course, in alveol type also there is an issue if one star is small and one is big. Then also this eclipse times changes. Okay. Because when there is a maxima, that is okay. But while coming here, you will get both stars. So this type of minima, you will get both stars input on your sensor, and you will get some energy. Some photons are counted. Again, is maxima. But while coming here, you will get only this. This will not available.
Okay.
So the
small one won't be
minima
visible.
and maxima heights will be different.
Acha.
From that we can deduce, this is alveol type variable, but one star is big, one star is small. It may be a white dwarf, it may be a red giant.
Okay.
Sometimes, as I told, there are two stars revolving, there is a mass transfer. So you get the energy from the mass transfer also. So if the two stars are equal, then you get a sinusoidal wave. Okay. These are called as light curves. And these light curves denotes what the system is.
And that is what we are trying to find out here.
That is what we are to find out. Now you can easily see that if there is a mass transfer between this or these are rotating very fast. This because of the mass transfer, one star goes get bigger, one is smaller, Then it comes again because this gravitational pull is
Right.
more because the mass is increased. So it comes there. So it starts revolving fast.
Okay.
Or sometimes upon this recedes away. Then it becomes slower to go there.
Is it sometimes happen that once the mass transfer is done, one of the star disappears entirely?
That may be the experience that was we are trying to see. Because all stars we are seeing in the night sky are from our Milky Way.
Oh, okay.
It is we couldn't see stars from the other Milky Way, that is like Andromeda galaxy or something like that. What you see is our Milky Way.
How did we know that in the first place?
This is why there are major distances. And
Okay.
and it has some variable theory comes there. That is called as Cepheid variables.
Okay.
This is some variables are just as I'm saying. This is the eclipsing binary. Some is expand, some contracts. So while swelling and shrinking, this is a very peculiar thing, and the period depends on the distance. What we observe.
Okay.
So what we can calculate from that how far in the system is.
Okay.
This is how many of the variables from the Andromeda galaxy we are defined and decide the distance between them.
Okay.
The first one was using the triangular method.
Okay.
It is very easy. This is a parallax method. You stretch your hand like this and blink your eye. Then you get the background shifted.
Right.
So, astronomers use this for orbiting Earth. So if it is the sun, we are observing from here, is Earth. Again from here, you get a major baseline.
Right.
And so a star, the star which is nearer moves in the background of
the background
distant stars.
Okay.
So in that the angle is very small and it has some limitation.
Okay, but we have to wait for like
Henrietta Leavitt, which was employed as a computer at that time.
Okay.
Where there were no computers and there are glass plates on which these observations are made. And she was doing the classification of these variables.
Okay. Who did you say the name was?
Henrietta Leavitt.
Okay.
It is in, I think, 1900 or something.
Okay.
Some many years back. So, the variable stars are used for distance measuring. This is the thing. So there are two major things of the types, let us say, of the variables. That is, one is eclipsing binary, and one is that is called as intrinsic, and one is extrinsic. There are so many parts also. There are maybe star spots, just as the sunspots. So we get the variation. So our sun is that way variable.
Okay.
Then there may be some exoplanet is going on. So this can be observed by this method. This is not actually, the stars magnitude varies. The star's intensity varies. So you will get a small planet coming out of this and you are getting the eclipse like this.
Okay.
And that what we say light curve always denotes what type of star it is.
Okay.
So if it is exoplanet, then you will get a star magnitude constant of course, then drop like this. Then the long baseline comes up again and goes.
So is there a time period that we need to capture the same star over and over again?
There is a change in that.
Do they differ star to star?
They differ. They goes on increasing period or decreasing period. And that's why we professional astronomer needs amateurs. Because we observe all this is again and again and use our data, create their models of astrophysics.
Okay. So, sir, we have a lot of satellites or telescopes out there orbiting the Earth.
Right.
Not on the ground.
Right.
So, how are these observatories more helpful to the professional astronomer?
Right. On the first hand, we have developed, America and Europe countries developed the telescopes which has a huge diameter, 4 meter, 5 meter, 10 meter telescopes, and they are on the ground. So the turbulence because of the atmosphere, which we call it as a twinkling, falls on the sensor.
Oh, so the stars don't twinkle.
The stars don't twinkle.
Okay.
The atmosphere makes them to twinkle because of the layers in the atmosphere. When the starlight comes, then it goes like this.
Oh, okay.
So when you are reaching the ground, it is too much.
Hmm.
So these observatories were higher, like Mauna Kea or Hawaii. They are above the clouds.
Here
So
also we
you-
have Hanley Observatory.
Hanley Observatory also. So this thing will comes very small.
Okay.
Still, the periscopes are big,
Yes.
so sensitivity is big. So
Right.
there is a problem. So to avoid this, we shifted from Earth to above atmosphere. So Chandra X-ray telescope or Hubble Space telescopes or many telescopes are there which are above our atmosphere. So there is no night or day. The
Right.
sun is here, then you can see a star next to sun very easily because there is no atmosphere. We can't see it because of their atmospheric dust particles. That is not
Because of the
available,
scattering.
there are the scattering. So it is not available in the sky,
Okay.
rather in space.
Outer space.
Now this problem is this: when we go up and up, the maintenance becomes very difficult for it is because of the astronauts has to go there, do the things. Then the finance is also an issue. So nowadays there is one more things come up where when the mirror is there, then it is a fragmented mirror.
Okay.
It's not a single mirror.
Okay.
So there are very small parts like 2 meter, 2 meter, 2 meter. They may be hexagon, and they have some actuators at the bottom. So as this wavefront comes and hits here, this part gets adjusted and
Okay.
nullifies the things.
Okay.
It is called as adaptive optics.
Adaptive
It is
optics.
called as
Adaptive optics.
So it nullifies the things. And you get so the problem we face because of the atmosphere is nullified.
Okay.
So it is become very easy for this. There's a
On the ground
on the ground
telescopes.
we can again do the things right now.
Okay.
Many of the telescopes have this type of facility nowadays, and they are very fine.
Okay.
And the atmosphere is not making any disturbance to the observation.
Okay. So those will be the professional grade telescopes, right? So why this observatory? Why the amateur observatory?
Because as I told, they don't have time to do this.
Okay.
And they don't have the access to telescopes also for the unlimited time. The telescopes are big. Someone is observing galaxies, someone is observing dark matter, someone is observing.
So that is more of a shared telescope.
So the telescope cannot be shared for everything. If you are getting a light core in a one day, you have to take observations for a few seconds each from to a whole night.
Right.
So that is not possible. Again and again doing that. So we can do that.
Okay.
And we can do, if the sky is good, then we can go for this type of system, we can go to the 16th magnitude stars. So what is the magnitude now? That is the intensity.
I was coming to that. Yes.
That is the intensity. So in this intensity, what happens is when we see the stars in the old days, they have done some faint star and bright star. They're divided into 6 parts. So first magnitude, second magnitude, third magnitude, fourth magnitude, by unaided eye. And after that, when the sensors and come that they come to know that the 6th magnitude star is a fainter star, 1 magnitude is a bright star.
Okay.
So it is the opposite. As the number increases, magnitude decreases.
Okay.
That is the intensity decreases.
Okay.
And the sun
can we call it the brightness decreases?
Brightness decreases. You can solve that. And the sun is minus 22.
Okay.
Full moon is minus 12.
Wow.
Jupiter is around minus 1 sometimes when it is nearer. Then Venus minus 4 when it comes near. It also, as it elliptical orbits, it go away from us, and this is also. So while doing this, from 1 magnitude to 6 magnitude, there is a drop of 100 times.
Okay.
It's a drop of 100 times in logarithmic scale. From there you can calculate, if I go to 16, what is the percentage that we can see, that is around 300 times or 400 times fainter stars we can observe.
Okay.
And how we can make it? Very easily, because of this type of telescopes. This is a 12-inch telescope. That is 300 mm is the diameter. What we observe from our eye, we have a pupil.
Hmm.
and you get all the information in the pupil, which is 3 mm diameter.
Okay.
And you are using now the lens that is like
That is
Spexis, which is
which is
300 mm,
300 mm.
100 times more. So
Right.
you get 100 times more energy.
More light.
So more like, of course, there is a fainter we can see. So the telescopes are used for that.
Okay.
So from Pune city like this, where
Hmm.
is a polluted city,
Hmm.
we couldn't see at 2 minute stars also very easily. But from this type of telescope and in a head-on, we can go up to 9-10 magnitude.
Wow.
So why we are here? Why won't we go to some place where there is no polite pollution?
Right, right.
This is because we are amateur astronomers. Everybody is working somewhere else.
Okay.
Every student is doing something else.
Hmm.
So if he wants or she wants
Hmm.
to do the things,
Hmm.
do the observations, if she has to travel for some 100 kilometers, 200 kilometers, then that will be a problem for her or
Hmm.
him.
Hmm.
That it is not possible.
So
And when you are go to remote places, then there will be internet issue, there may be the transport issue, food issue,
food issue, other
the
logistical issues.
other basic safety may be the issue.
Hmm.
So we are sitting here
Hmm.
at the center of the Pune city. Everything is set. This is of the Kesariwala Jyotirvidya Observatory. This Kesariwala belongs to
Hmm.
the
Lokmanya.
Lokmanya Bal Gangadhar Tilak, which has his contribution in Kalgadna.
Kalgadna.
That is the Panchang or Almanac.
Okay.
At his time, he died in 1920.
Hmm.
But so when our students or some observers come here, they should not hesitate. They should not have any issues other than sky. If the
Okay.
sky is cloudy, can't go for that. But this place is connected by metro. This connected space connected by bus. You can come with the two-wheeler. It is at a central place. Then there are so many hotels over here. So in that there is a you can have
Food.
get transport and food up till late night 11, 12 o'clock. So there is no issue.
Okay.
So
this
what
was
we have to do? We have to go for the bright objects, which is below 9 magnitude stars.
Hmm.
That's okay. There are thousands of stars.
Okay.
We have more than thousands of stars, which you have to observe in
Hmm.
this scale.
Hmm.
So this is the magnitude scale which we will talking about.
Okay.
So let's
So
observe
we are
them.
not really losing
And
out on it.
second thing, the big telescope
Hmm.
has a saturation point at 10 magnitude.
Oh, okay.
So they couldn't observe less than that.
Okay.
Because the mirror is big.
Hmm.
If the bright object is there, their sensor gets overrated.
Right.
So
Just like we have to close our eyes a bit
Correct.
in the out in the sun.
Correct.
Yeah.
This is how. So they couldn't bring their eye.
Hmm.
So there is no issue.
Right.
So these observations are needed. Likewise, for the last few years, 2 or 3 years, something going on with the Betelgeuse, which is in Orion. There is a red giant, and that may explode.
Hmm.
From where this knowledge comes?
Right.
Not by the professional observers.
Oh.
This is from amateur
Amateurs.
astronomers.
Okay.
Just giving that data to professionals, they find it in a perfect way,
Hmm.
and
They do the
they do
calculations.
calculations and come with a exciting ideas what will happen, and it doesn't. But the base is
Hmm.
observational basis, amateur astronomers, because it is a 2 manual star. It's very
Hmm.
bright.
Right.
It's very bright. So
Okay.
even if our telescope
Hmm.
gets saturated by that star,
Wow. Okay.
when we are going for the exposure of 0.1 second.
0.1 second and we get saturated by
Saturation
Betelgeuse.
Up to 5 magnitude, we get the saturation
Wow.
for 12-inch telescope
For a
in this city.
In the city.
They are in the remote places. They are at the fantastic environment over
It
there.
must be blinding for
So
them.
they can't do anything.
Hmm.
So we are there.
Hmm.
So for this, you have to go for the smaller telescopes.
Hmm.
So for the smaller telescope gives you good resolution, and they can give you the right curve of the Betelgeuse or some many stars like this.
Okay.
So we are doing is fine. So we have our B.Sc, M.Sc projects over here, and they do calculations for this. They see they take observations from December to March. This is the season for
The
us.
winter sky.
Because in India we have monsoon, and it starts generally from May and ends around December in Pune. So else this 3-4 months what we get a fantastic sky most of the time,
Mhm.
and these people, there are basically people who generally go only for variation, that this is the variable star, it varies like this, and the light curve is like this and all things. For M.Sc, they have to calculate the period, change in period, and the reason behind that.
Okay.
And for PhD students, it is for the of the observations for the unknown variables. So
Okay.
we do that type of job also. We take a open cluster or closed cluster and photograph it. We have some standard stars in that, and check whether the stars are variating or not. So if it's variating, then go for a period. If the period is, you get the period, you get the prediction for the next observation. If it comes true, then you get a period. This is how we do.
Wow. So not only you
So-
are helping the professionals, you are also helping the kids to.
we are Jyotirjapa is the bridge between professionals and the amateurs.
I had this question earlier when we were discussing about the dome outside, that when you say amateur and you said you are doing observations, and you also say people who are interested only in the night sky looking through the telescope, they are also amateur. So what is amateur for you?
Amateur, that means we are not earning any money out of these observations or something. It is just like just a passion. We want to do it for ourselves. We are not employed by this way, and we can go at starlight at our own. No bindings on it, so we can enjoy the things. If it is compulsory, you have to go and watch the things, then it becomes a difficulty. Because there are something going on. I have my fabrication workshop. I have to work for in my workshop from 9 o'clock to 6 o'clock. After that, if I want to go for my hobby, then this is the hobby. And everybody
Adding
comes like
fun
this.
to your life.
Everybody comes in here. They want to do something. Generally, school kids or something comes. I want to do something in astronomy. In Pune, it is very popular, but they don't know what to do. So they say, okay, fine, go for a star party, see the stars, constellations, rashis, nakshatra, their shapes and sizes, mythological stories, everything you can get.
So we do that in
so they see the
Jyotirvidya
telescopes,
Parisanstha as well.
so they go to star parties, see the telescopes. There are Jupiter with moon, Saturn with ring, then craters on the moon and everything. Some open cluster, global cluster, some nebula like Orion, Neron. But after that, what? The problem lies there. If I want to pursue again, I have seen through the telescopes.
Yeah.
There is a limitation for that now. How many times I will see the craters on the moon? Once, twice, thrice. Then that will get bored. So if I want to do astronomy once again and I have this basic knowledge, then I'll go for the. We will suggest them to go for the variable star observations or occultations. Or meteor shower observations, which are internationally needed things. So we have to plan the observation now. You go for somewhere else. If we are going for the meteor shower, you have to plan the things. You have to plan the timings. You have to plan for the occultations. You have to go in the belt to see the asteroids and everything. So this you get a sorted thing. You help a professional astronomer. That gives him immense happiness. That absolutely, I can show you some mails. We got these mails many times from AVSO, that is American Association of Variable Star Observers. This is.
Are we a member of that?
Yes, I am a member of that, and around 75,000 observations are posted there from us.
Wow.
From here.
Brand new data.
Brand new data.
Wow.
Absolutely brand new data. So where is the mail? So I can show you Gmail, and you will get it today.
Oh.
This is today, 1737. This is no reply from AVSO. Just open the mail and you will get that. These two stars, W Uma and Y Persei, which we observed, our 12 observations from the W Uma and 229 observations of Y Persei are used somewhere in last 7 days. You can see the data usage report, weekly summary of the data downloads from the AVSO.
And it could be used for observations, for calculations.
Calculations and everything. And when you say that it is a professional, it is amateurs or student. So many times professionals are there who downloads our data, and it is a fantastic. They are observing our data,
That's spectacular.
and we are happy about that. That what we are doing, they are downloading and making there some models or something, and new things may happen.
Yeah.
And if they use our data, JVP's name will be there
Awesome.
after their projects are completed.
That's beautiful.
So let's close down.
Sure. Thank you very much,
Thank you very
sir,
much for
for letting us know what an amateur spectrum could be and how we are making some real life impact, not only just sitting out here and looking at the sky,
Correct.
but actually helping the professionals in making better observations and improving their
Right.
the course of astronomy.
So just one step ahead.
It always starts with
But
each
it's
step.
amateur activity.
It is an amateur activity.
We don't charge anything. Jyotirvidya is a organization which is we have volunteers. Of course, from for running the observations or something we need money, and we don't want donations.
Okay.
We just earn and learn. So we go to staff parties. So we earn from the staff parties. We earn from the basic astronomy course, which is 1 month long course. We go for the exhibitions. We go for the study tours to see the big telescopes like 4 meter, 3 meter, 4 meter telescopes which are in the India, and we earn money out of that. No volunteer takes any money.
Okay.
It is completely free from the volunteer, and what money we receive goes to the association's account, and from that we can use this type of observatories. Uh, in say up to 1995, we have only one telescope with us, which is a 2.5 inch refractor.
Oh.
Now we have 20 telescopes which are automated. This is a big dome. We have everything because of all our volunteers worked, and they want to do something. Because if you want to purchase a good telescope, it may cost you around 10 lakhs. And for hobby, 10 lakhs is a 10 lakh rupees is a good amount as far as Pune culture is concerned. So what we do, we collect the money like this. So you can use this facility anytime and goes for the observations and everything, and you get all the things done.
I have also heard that JVP has a unique feature of having a telescope library.
Telescope library we have. With a small telescope we give for our members to observe the things.
Oh, it's like we can take a book home, we can take a telescope home?
Right. You can take the telescope home. The only condition, there are two conditions. One condition, you should be a member of Jyotirvidya Vyavastha. There is a free library over there. There is no charges for that. And there must be something observational you should have planned. If you are going to take the telescope from to home, then you should have some aim to that. The aim may be something that I have to show planet to my in my society or my kids or my girlfriend. That's okay.
It doesn't have to be something on paper.
No. You have to use the telescope. That's all.
That's all.
You got it from home and don't use it. That we won't permit. You have to the
There's
reason
no
may be
point in
something.
that, yeah.
Reason must be maybe something, but
Yeah.
you should do something with
Should
the
not be a
telescope.
dead weight.
Correct.
Yeah.
Otherwise, someone else will use it.
True.
That is the only thing. That you do something with that. You go with the telescope, see something. You see Saturn. You see moon occultations. Lunar occultations are always there, which can be seen from our telescope. You can record it from our telescope. You can attach a camera to that. Your camera, of course.
Of course.
And get a photography done. Some telescopes are automatic, some are manual. So it depends on what you have to do. You can go for the mini star party at your terrace for your colleagues or let us say some in your society. We don't have any issue. But to use that telescope to enhance your knowledge and others also.
And if we want to find you anytime, are you available in this observatory, or is there some place else that we can refer to?
We have our office at TX Smarak Mandir, which is on TX Road near SV College. This is the it isn't TX Smarak Mandir is a monument itself, so you can find on the internet very easily. And we are there on every Sunday between 6 to 8 p.m. as we are employed somewhere and we are doing all this night, it is not possible every day to open the office. The office opens only on Sunday, 6
Okay.
to 8 p.m.
Okay.
evening. And you can come
So
there.
membership and everything occurs.
If you want a member, it is online. We have our site, jvppune.in or jvp.org.in. Both are working, and you can go for that. There are membership you can take from the
Online
site.
site.
And there are 3 types of membership. There is a student membership, there is the annual membership, and there is a life membership. The
Okay.
student is up to 12 standard.
Okay.
After that, annual membership starts,
Hmm.
and life membership is life membership.
Awesome.
So you can come over there. Even if you visit our site, jvppune.in, then there is a one block is join. And the homepage also. If you join,
We can register
you can
directly.
register there. You should not. It's not necessary you to be member. Just register your email ID over there, so you will get the notification of our all programs on your mail.
Wow.
So you will get notified. We are also on social media. We are in the Facebook, Twitter, then Instagram, everywhere.
I think it's astrojvp.
It's Astro JVP.
Yeah. Okay.
So thank you very much.
Thank you very
Let's
much,
see
sir.
how these things goes up.
Sure, definitely.
Yeah.
Thank you very
Thank
much
you.
for this brief introduction about the observatory.
So
It was really fun.
List, I have to do some work for that. It is Control C. I have to exit. From Raspberry Pi. So I exited. So I can close this. And that's done. I can close this
Remotely as well.
remotely also.
Okay.
So that is not an issue.
Yes. Thank you very much,
Thank
sir.
you very
Thank you
much.
for
Thanks
this.
for coming.
Thank you. Hope to see you again soon.
Yeah.
Thank you.
We are here full night most of the time.
Yes.
Of the and now the moon is there.